Hello. So may I know your comment? May I know your comment on the method which I've used above? Yes, that method of sine rule in this particular triangle. What's your comment? Okay. Let me remind you, we solved using the sine rule. We solved using the sine rule, and we got a y. We got a y to be equal to 28.2 centimeter. Do you remember? Okay, now let me take you to method 2. Let me take you to method 2. And what's the method 2 about? Method 2 is about using this familiar formula of SOHCAHTOA. Okay, I know you are very familiar to this particular formula here. That is sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, and the tangent equals opposite over adjacent. So analyzing our diagram critically, you will learn that if this is the angle, then this one here is the adjacent side. This one. That's the adjacent side. This side here is hypotenuse, and that side here will be the opposite side. Do we agree? If that's the case, then let's select of these three trig ratios, which one should we use? What do we have and which formula should we use? Yes, you will realize that this question involves these two sides because you're taught to solve for y, and we have 30 this side and that angle. So it means we are going to find the relationship of a trig ratio which involves the opposite side and the hypotenuse, of which from this you will realize that that is sine. That is sine. So we shall say sine from this diagram above here. So sine of 70 degrees will be equal to opposite side, which is y, divided by the hypotenuse, which is 30 centimeter, which is 30 centimeter. Okay, we can make y the subject of the formula by simply multiplying through by the denominator of this fraction y over 30. So multiplying through, we shall have 30 times sine of 70 degrees to be equal to y, Since we are solving for y, then we shall say y is equal to the 30 times. Okay, what is the sine of 70 degrees? Remember, 70 is not among the special angles. So we shall have to use either a mathematical table or a calculator. According to me, the nearest, the easiest, and the more available is the calculator. So the sine of 70, okay, sine of 70, this one gives us 0.9397. 0.9397. So when you multiply by 30, multiplying this one by 30, this gives us 28.191. But we are told that the answer has to be to one decimal place. So we can say this is approximately, we're approximating this one to one decimal place. It will be 28. Okay. One decimal place, let's look at the first digit, which is 1. But before we write this one, we have to look at the second digit and see if it's above 5 and above. Okay, for this particular case here, we have 9. So 9 is 5 and above. So this one rounds off to add to 1. So we take 1 here, add it to 1, and we are getting 28.2. This is centimeter, 28.2. So our conclusion, you realize it's the same answer. That is, therefore, the value of y is 28.2 centimeters. 28.2 centimeters. Okay, so can you see we are getting the same answer? Whether you use the sine rule or you use the trig ratio concept of SOHCAHTOA, you still get the same answer. I had to take you through that method, which is a bit advanced, so that you can learn new concept apart from this one. So which one is better and which one applies where? Here is the explanation. Here's the explanation, so I want you to pay attention. Here we go. Okay, when do we use sine rule and when do we use this one? This particular method of SOHCAHTOA applies only to right angled triangle. It applies only to right angled triangle. That is a triangle like this one with this square box in one of the corners signifying 90 degrees. So this one applies only in this particular situation. But if it happens that you have a triangle with no 90 degrees, okay, let me try to restructure the same diagram to see. You have this, for example. Now this one is not 90. Let's make it 120. Okay, maybe let me do it this way. Then I do it this way. Then like this. Okay, you can see the concept. Okay, then I put my 70 here. Assume our 70 is there. Then where is our y? Our y is this side. Where is our 30? Our 30 is this side. Okay, you see, they're almost similar diagrams. The positioning of the angles is similar, but the size of the angles are different. And in this diagram number 2, this one, we don't have a right angle, that is this symbol, or we don't have a 90 degrees. Okay, though in the calculation we realize that this one has increased the size, so definitely this one we have to decrease in size so as to make a total of 180 degrees in this particular triangle. So for this particular case here, you cannot use the SOHCAHTOA concept here. It doesn't apply. Okay, unless you have to force it, you should have extra information, maybe where you can have the height, put the height somewhere there, but you have to know this distance from here to here, then here to there. Actually, it's a bit complicated. It's a bit complicated, but you can just assume that from here to here is x, then that side will be 30 minus x. So it's a bit complicated, but the easiest way to do this particular question here is by using the sine rule. So you realize that the sine rule applies to both situations, to this right angle triangle as well as to this one here. So I think that's the explanation I can give you for today. You can put your comment if you're satisfied with this explanation, but don't forget also to share this information to your friend, and follow us for more tips in mathematics. Thank you.